When you're trying to decide how many people from a group to pick, there's a type called stratified sampling for if your data is in particular groups already. So, for example, I might be interested in finding out whether being part of a sports club affects your healthy eating styles. I've already asked a group of students how many of them are part of a sports club, and in year 7 there were 80, in year 8 there were 50, and year 9 there were 70 students. If I just randomly picked the number of people that I want, I'm going to go with a sample of 20, then I might, just by chance, get all 20 of them from year 7. And that wouldn't represent everybody very fairly. If I did a systematic sample, then it might be again that just because of the way the lists happen to be, that I just hit quite a lot of year 9 students and hardly any 7s or 8s. And again, that wouldn't seem a fair representation. So stratified sampling makes sure that I pick a fair proportion from each of these groups. So I'm going to get a fair amount of year 7s, year 8s and year 9s based on how many there were. So to conduct a stratified sample, first thing you do is add up the total number of students in this case. So 80 plus 50 plus 70, that comes to 200. Then I need to work out what proportion of my sample size to take from this year group. So in year 7 there were 80 out of the 200 students, and I want to times that by my sample size. I want 80 200ths of 20. So 80 divided by 200 and then times by 20. It says I need 8. So I'll be picking 8 year 7s. And I just do a similar thing for the other year groups as well. In year 8, that's 50 out of the 200 students, so 50 200ths times 20. 50 out of 200, that's a quarter. Quarter of 20 is 5. And for the last group, 70 out of 200, and then times by 20 as well, because my sample size is 20. So 70 out of 200 times by 20 is 7. So I need to pick 7 people from year 9. Once I know how many from each year group I need, you still need to go and randomly pick 8 out of those 80. So you could do opportunistic out of the year 7s, or maybe systematic out of the year 7s, or perhaps you just want to use a random number generator to pick 8 year 7s, 5 year 8s, and 7 year 9s. One more example of the same sort of thing. I'm looking to get information about whether people think a youth club would be a good idea. And I've got members in a village, 40, 70, 120, 180, 60 and 30 in different age groups. There are 40 villagers between the ages of 0 and 12. I want a sample size of 30, but I don't want to just ask the 13 to 24-year-olds, because obviously their opinions are going to be a lot different to the people in the 60 to 80 age range. I need a good representation of all of these age groups. So the first thing to do is to add up the total number of villagers. That comes to 500. It's got 500 people altogether. And then for each category, I need to do the number of villagers in that group divided by the total number of villagers. So I'm finding the proportion of people that are in this group, 0 to 12. That's 40 500ths. And I times that by the sample size I want. So 40 divided by 500 times my sample size of 30 tells me I need 2.4 people. And we're going to go through and do the same thing for each of these other groups. 70 divided by 500 and then times by 30. So I'll just go through and do that for the rest of them as well. So I've calculated it for all of them. I sped that calculations up in case you're wondering. There is a bit of a problem. I can't really pick 2.4 people from this group. I can't pick a decimal part of a person. So I'm going to have to round these. So 2.4, I'd round that to 2. That's closest to 2. 4.2 is close to 4. That's close to 7. This one needs to round up to 11. This one will round up to 4. And this one will round up to 2. Just check that I've got the right number of people I wanted. So 2, that makes 6. 13, add 11 makes 24. 28, and that does give me the 30 people that I wanted. Sometimes that doesn't quite work out and you get one too many or one too few. And if that's the case, then just add one or take one off of your biggest group. That's the one where it's going to be least noticeable. So for stratified sampling, you really should do this if you've got different sized groups. If you've got a lot more females than males, for example, and you're doing something based on gender, then you should pick the number of people based on the number of people in that group. The sample that you pick from each group will vary in size. Stratified sampling is one of the best ways of getting a good representation of an overall population, and generally speaking you do it by picking the size of the group, you divide that by the total number, and then multiply by the sample size that you want. That tells you how many to pick from that group.